So 1988, you start, you're having some success, obviously you're growing to a point where you decide that you want to use unmanned aircraft.
Yes.
When was that? How did that happen? Tell us a little bit about that.
Yes, in the mid-90s, we were limited to what we could do with a manned helicopter in terms of low, mid-rise projects, and I started researching who I could partner with to pilot RC helicopters, which is what it was called at that time.
Of course.
Way before drones became a constant. And in the mid-90s, I teamed up with a gentleman from Rockford who had been flying RC for many years and had used cameras as well.
Excellent. So what aircraft were you using then?
That's a good question. That is so many systems ago, I'm not sure I can remember, but
Okay.
it goes back to certainly gas-powered, nitro-powered machines. Yeah, everything was pretty much custom made. We would start with a standard kit, and then we would change blades, motor, tail, boom, length, and engineer it to carry weight so that we could actually shoot with larger camera support systems and cameras, as well as front mount video systems.
So what was the camera size? Obviously, you have to have an aircraft large enough to carry the weight of the aircraft and the payload as well.
Yes.
What kind of size camera were you using?
And to be stable so that when we
Right.
shot pictures, we could stay in somewhat the same XY position while we were
Right.
in the air.
Right.
We were using Panasonic video cameras for our footage, which were front mounted with a system that we designed ourselves for stabilization. And then below the ship, we were utilizing a custom made rotating mount, which used Canon EOS film cameras at that time.
Yeah, they're very popular still, right?
They are. Their digital cameras are the best.
Some of the best.
Yeah.
Excellent. So that's great. How did you see it progress, and what were the difficulties that you were having? So what year? Let's start off with what year we're talking about you actually started. Do you remember what year? Mid-90s?
Yes, around 96. About 20 years ago is when I first met Jeff Jones, who's my partner in Skypan, and we started experimenting first with video and then utilizing more still equipment and systems to support the camera, stabilize the camera, and to create better imagery constantly. It was difficult because we had to hand make everything. Our landing platforms, which would protrude and then recess so that the camera would have views all the way around. We tried many different type of helicopter systems. I think we went through 8 different systems. Wow. Because they were being made by different individuals at that time. Right. Around the US, all with their faults and positives. Right. We even used a twin engine craft at one point, which was a real beast to transport and to maintain. We were very glad when we got into the 2000s, 2002, 2003, and things became electric.
Awesome. Yeah, because electric is a lot easier and cleaner and much better to deal with, but although gas-powered are more powerful.
Yes, and we never had to worry about losing power.
Yeah,
because
right.
with the electric, we're limited to 6-7 minutes maximum, even
Right.
with a large set of lithium polymer batteries.
And that happens
true.
fast.
Yes, it happens fast, but our operations tend to be very quick too, because most of what we do is straight up, straight down over proposed building sites.
Right, that's great. So, and as you were saying, you had to construct the landing gear where it would pull up so that you could get that 360-degree view.
Yes, and in the early days, we didn't have that type of lightweight gear or equipment to work with, so we would work with extended poles below the helicopter that we would land and take off on frames that we would build. And that was very dangerous because the camera was always hanging down and potentially getting hit or maybe creating a situation for an accident.
So the lowest attachment on the aircraft was the camera. the most valuable part of the whole system.
Correct.
And you're landing, and the camera's still hanging below your skids.
That is correct, and we had many times where things failed and the camera would be destroyed before anything else.
Oh man, now that's expensive.
I think we went through 6 separate Panasonic video cameras, which were front mounted but also destroyed, and I can't remember how many still cameras.
Do you have any idea at this point, it's going back a ways, but what the cost of the aircraft were back then? You're talking about custom design, you'll take something off the shelf, right? But basically custom design it. So almost from the ground up with parts.
The basic kits were running a couple of $1,000s. By the time we tooled them up to our needs and added a camera mount, they were probably in the $5,000, $6,000, $7,000 range. But it's hard to judge because so much time went into improvements and into changes in motors and blades and various elements to make them better lifters and better workhorses.
And you can't quantify that, the amount of time that you put in customizing the aircraft.
Not really, and that doesn't include camera equipment.
Right. What wingspan or prop span are we talking about for these?
We were working with 800 plus millimeter blade lengths at that time, and to this day we still tend to use 700 to 800 millimeter blades with a single prop helicopter platform. And the reason we primarily use that is because it's safer than a multi-rotor. It's more difficult to maintain and fly as a pilot, but it is safer in several respects. One is with large blades we have no wind issues because we can run into big gusts and it won't blow around much because those big blades really dig in. Also, we can control the ship just like a full-scale manned helicopter in that we can auto-rotate down if we were to lose power for any number of reasons.
Right.
And you cannot do that with a multi-rotor.
No, you can't. And it's much more powerful, that one big blade, right?
It's more powerful and not necessarily more stable. It just depends on winds and positioning, but it's something we started with and that we understood and had a good experience with and chose to stick with because we are carrying 8 to 10 pounds of camera platform and equipment, downlinks, etc., for every flight.
That's a big load. Plus plus the weight of the aircraft. What we're talking about, 30 pounds all up.
All up, it's around 20.
20? Okay.
Yeah. Around 20 pounds. We've got it slimmed down.
Wow.
And there are multi-rotors now that will do heavy lifting, certainly, but there are issues with them that don't work for us. For example, frequently we were using a very wide lens, even fisheye lenses.
Really?
And so we always have to take the tail out of the image when we're doing a full 360 panoramic.
Right.
If we use a octocopter, now we have 8 tails to remove.
Right.
So that makes it a lot more post-work.
So digitally removing it. Right,
and that's a lot of work.
Post-work,
and it's very difficult, especially if you're on low levels, have buildings nearby that are behind the tail. So now you're having to recreate all these elements, and it's not easy.
And you wouldn't have the aircraft and spin the aircraft around. That would not be an option.
It's not an option because as soon as you start spinning an aircraft, you lose your XY position.
Right.
And it's much easier to hold it into the wind and stay utilizing GPS and other electronics to spin the platform below.
Right. So you would go up to a level, hover there, go up to another level, hover?
Correct.
Okay.
And we only need between 2 and 3 seconds to shoot each elevation.
And were you using GPS at the time, or is that?
No, our early days were
all manual.
All manual.
Wow. So you're using an altimeter?
We are using altimeter. We've been using altimeters for many years, so we know exactly our height within a foot generally. And we started using GPS, I'd say around 10, 11 years ago.
Wow.
When good GPS systems were available to help us with stabilization.
And miniaturized enough where you could actually use it.
Correct.